The relativity of time. According to the relativity of time, moving clocks are measured to tick more slowly than an observer's stationary clock. Let's take an example. So, let's say we have a spaceship traveling at some speed, let's say 1/2, so half the speed of light. On this spaceship is a clock. Okay? This clock is ticking, this clock is ticking, and also we have a person at rest, and this person is holding their own clock. Okay, and this clock is also ticking. Now, the time, so we have this equation, t equals t sub 0 divided by the square root of 1 minus v squared over c squared. T is the time observed from a fixed frame of reference. So that would be this clock here, so the time on this clock. And then t sub 0 is the proper time in a fixed frame of reference. So this is the real time that's happening at a fixed frame, so at rest. So this is t sub 0. Now, according to special relativity, according to the relativity of time, the clock that is moving is going to move more slowly than the clock at rest. So therefore, t will be less than the proper time because it's moving more slowly. Now, as this object approaches the speed of light, time will move even slower, and will move slower and slower as the speed increases. Now, hypothetically, if we were in a spaceship traveling at the speed of light, a certain amount of time would go by, and back on Earth, that time would be of much greater much greater than the time that we experienced on the airplane or on the spaceship. So for example, 1 year could go by on the spaceship, and that could be the equivalent of, let's say, 10 years on Earth. Okay? We can determine those actual times using this equation.